So we need to find the maximum height reached by the rocket. To calculate the maximum using the TI-84 plus CE calculator, we go to second and trace, which is actually calculate. We're going to go to option number 4 to find the maximum. To find the maximum, they're going to ask us for our left bound, our right bound, and then they're going to ask us to guess it. Here we can see that the maximum is 6. We can also do it by hand by using the symmetrical formula to find the maximum, which is negative b over 2a. This gives us the x value. To get the x value, we substitute a and b. A is going to be negative 0.2. B is going to be 2.4. And we get 6. This is where we have our maximum. So when x is equal to 6, we will have our maximum. Our maximum will then be 6 plugged into the formula to find out our y, which is going to be the vertical height. At 6, our vertical height is 12.8, which is what we get with our calculator. For part B, we need to find out the horizontal distance when it returns to the same height when it was launched. It was actually launched at 5.6 meters. But that's not really needed since we know that this parabola is going to be symmetrical. It launched, and then 6 meters after it reached its maximum height. So we can calculate the value in which after 6 more meters, we will have the exact 5.6 again. All this because parabolas are symmetrical. This means that the distance it travels until it reaches to 5.6 is going to be 12 meters. For part C, we want to find the distance in which the parabola reaches, again, the ground. To find this using the calculator, we can go to second trace, which is calculate. We can now find the 0 and find out exactly this point where it crosses the x-axis. Using our calculator, we found out that the 0 is 14. A different way to do this is using numeric solver. If we use numeric solver, we set the equation equal to 0. That's going to tell us exactly where it crosses. There's actually 2 places where it crosses. There's another place on this side. But we know that our x has to be positive because it's going to be the time after it launches. This number would give me a negative value. As we can see with numeric solver, our answer would also be 14. So the vertical distance until the rocket touches the ground is 14 meters.